Right, welcome. We are looking today at trigonometry, very interesting section of mathematics. It's got a whole lot of things that you will learn, and this is the introduction of the basics that you need to know, from definitions to how trigonometry actually is used in determining missing sides or missing angles. But for now, we just want to keep the basics, want to learn the various definitions and ratios and functions and what trigonometry is at the end. Let's start with that. What is trigonometry? If you look at the word trigonometry itself, it's got trigono and it's got metry, which simply means the measurement of three-sided figures. In this case, triangles. The basis of the introduction of trigonometry starts with triangles. And in fact, it's sitting on triangles, but specifically right-angle triangle in grade 10. Now, let's have a look and see how is this related to triangles. Well, trigonometry is just the study and also an area of mathematics that deals with the relationships that are between sides and angles in a triangle. And in order for us to do that, we use functions of angles, and that's one of the things we're going to learn. What are the various trig functions that we use that helps us to actually determine exactly that relationship between any sides of a triangle and its angles? Let's start with the actual definitions of the various trig functions or ratios that we're going to talk about. There's sine, there's cosine, and there's tan, okay, which is tangent. But in mathematics, we've got a short form of these trig ratios that we use. You'll see them on your calculator as well. They make it easy for us even to do calculations rather than use full words. Sine is sin, and cosine is cos, and tangent is tan, okay? But each one of those trig functions, you can't just say, oh, sine what, cos what, tan what. They go with angles. And if we don't have the angle or we don't know the angle yet, we'll then use a variable. And sometimes we use the Greek alphabet. We can even use our own alphabet, X's and Y's, but you'll find some of the Greek alphabet being used as well. The definition for sine is opposite over hypotenuse. Now, we'll explain later what that means because it's important to know what this ratio actually means in a triangle. And the other one is adjacent over hypotenuse, that's cos, and tan is opposite over adjacent, okay? Very easy way of remembering this is using SOHCAHTOA. Now, what does this mean? Clearly, we've just taken only the first letters of all those definitions and their trig functions or trig ratios. Sine is opposite of hypotenuse, and then cos is adjacent of hypotenuse, and then tan is opposite over adjacent. So pretty easy. You just have to remember that and use it to remember your definitions. You're going to use it quite a lot in solving or working with triangles, especially right-angle triangles. How to read ratios from a triangle? Well, let's take an example of a triangle ABC with an angle alpha and angle theta there. That's the Greek alphabet. And remember now the definitions are going to come in handy here. That's SOHCAHTOA that we talked about. We already know a right angle triangle has a hypotenuse. That's easy to identify. It's always the side opposite the right angle in your right angle triangle. You've done that since grade 8. Now, when we now look at the other two sides of those words we're using there, the other two sides, BC and AC, will alternate between opposite and adjacent, meaning they can either be called opposite or called adjacent. There's no side that is sitting there like the hypotenuse that is called or is the only side called opposite or adjacent. So they will depend on the angle you are talking about and angle you are using with reference to what they are called. Are they opposite the angle or are they adjacent to the angle? For instance, if we look at alpha, the side BC is adjacent to that, is next to that angle. So that will be the adjacent side to angle alpha. And if we're looking at theta, BC is opposite angle theta. It's not next to angle theta. It's not adjacent to angle theta. It's opposite angle theta. And yet when you look at angle alpha, the side AC actually is opposite angle alpha. So it's very important then to look what angle am I being referred to so that I can then use the correct name for the side in question to write my ratio. Okay, so it's very, very important. Opposite, adjacent. Okay. Hypotenuse is pretty easy, will never change, it will always be the hypotenuse. Now, as I said, these two sides, these two shorter sides of your right angle triangle will always interchange between being opposite and being adjacent, depending which angle you're talking about, okay? Let's now have a look, something important that you'll find in trigonometry, used quite a lot. We name the sides based on the angles opposite those sides. So the side opposite angle A is small letter A, the side opposite angle B is small letter B, and the side opposite angle C is small letter C. This is just to differentiate between angles and sides. And obviously your angles will be capital letters. Now, using our definitions, what will be the sine of theta? Now remember now, the definition for sine is opposite of hypotenuse. And look at the angle we're dealing with here, is theta. So that means for the ratio, we need the side opposite theta, which in this case is A, and the hypotenuse, which is C. Very important. What if we're talking about sine alpha? That's different because the side now opposite alpha is B, and the hypotenuse is still C. So very, very important when you get your ratios to actually use the correct definition for your trig functions or ratios. And then cos theta, remember cos theta, the definition is adjacent over hypotenuse. Hey, that's easy because now we're looking at angle theta. Which side is adjacent to angle theta? And that side is AC, which is B. Okay, now remember why we can say AB is adjacent is because already it's called the hypotenuse. So we can use that. As much as AB is next to angle theta, it's already got a name. It's called the hypotenuse. So that then leaves AC as our adjacent side, which in this case is B, and the hypotenuse is C. Hence, the ratio there for cos theta is B over C. The same goes for cos alpha. In cos alpha, which side is adjacent to alpha is A, the hypotenuse is C, so our ratio A over C. Tan theta, we look at theta using our definition for tan of opposite over adjacent. Opposite theta is alpha is A and adjacent is B. And then that will give us A over B, and then tan alpha, opposite alpha is B and adjacent is A. Let's now have a look at some examples. This one says use the following diagram to answer the questions that follow. The questions are asking you to determine the various expressions given there. And obviously when we work with this, it's a right angle triangle. We want to need our ratios. So your ability to remember the definitions is crucial and important. That SOHCAHTOA will help you here. So let's go. Let's have a look. First question. Definitely we're missing a third side there. We are forced therefore to do calculations before we do anything. We need that hypotenuse. It's missing. And that's where Pythagoras comes in straight from your grade 8. And don't forget your reason, very important. Every time you use Pythagoras in your maths, you must actually indicate your reason. And then simplify and solve for the missing side. In this case, that means our hypotenuse is 13. Now we've got a complete diagram now. We've got both shorter sides, we've got the hypotenuse. We're ready to respond to the question. We're asked to determine sine theta. Well, based on that, sine theta is 5 over 13. Why? Because that's opposite over hypotenuse, which is the definition for sine. In 1.2, we asked now to find cos alpha. Now we don't need to start anywhere because our diagram has got all the sides we need. Cos alpha, remember, definition for cos, adjacent over hypotenuse. So adjacent to alpha is the side 5 and then hypotenuse 13, so it's 5 over 13. Next one says tan alpha multiplied by cos theta. Okay, that's easy because we just need to read from the diagram the ratio for tan alpha and the ratio for cos theta, and that will be 12 over 5 for tan alpha, opposite over adjacent, and then 12 over 13 for cos theta, because that would be adjacent over hypotenuse. And then simplify fractions as you normally do. That gives us 144 over 65, and we're done. There were no common factors between numerators and denominators, so there was just a straightforward calculation of 12 times 12, 5 times 13. Next question, 10 squared. Want to remember this, very important. Here, that 10 squared actually means tan theta all squared. That is crucial. So find the ratio and square the ratio, and not the angle. Want to be careful there. And therefore tan theta, according to our diagram, is 5 over 12, and that means we have to square that 5 over 12, and that gives us 25 over 144. Okay, last question, 1,5, asking us to go cos alpha minus tan theta. Again, we just have to go and find the correct ratios there. Cos of alpha is 5 over 13. Subtract there the tan of theta, and tan theta being opposite of adjacent is 5 over 12. do your addition of fractions, get your answer, and you're there easily. Okay, so really doesn't matter what you ask to do, as long as you know and remember your definitions and then you apply them accordingly, you'll be able to get your answers here.